Hello and welcome students. This is a lecture on lines and planes, and right now we are working on the lines. Now as you know, when we say lines, we mean lines in 3D. That is three dimension. It is a part of three-dimensional geometry. So the topic is lines and planes, but we are right now working on lines, and after completing lines we will go for planes. So in lines, we have already done a lot of concepts. Now in this lecture, I'm going to teach you, we are going to discuss distance of a point from a line. So we are going to take 2 points here. In this first is we will take distance of a point from a line, and second we will take distance between two parallel lines. So let us start with the first one, that is distance of a point from a line. The first one is distance of a point from a line, and the second is distance between two parallel lines. Okay. So in short, if I have to explain, then see in the first one, there will be a point, there will be a line, and we have to get this distance. We have to get this distance in the first one. Okay. This is the perpendicular distance we have to find. This, say this is PM in the first one, in this one, and in the second one will be given two lines which are parallel, two parallel lines, and we'll have to find the distance between two parallel lines. Okay, we'll have to find this distance. So let us start with the first one. The first one that we have is distance between two parallel lines. So I'm sorry, distance between a point, distance of a point from a line. So the heading will be distance of a point P, whose position vector is P bar, from a line R bar equals to A bar plus lambda B bar. So what are we given? We are given the point, and what is the point? The point is P. And we are given equation of a line, that is we are given a line. So the first thing I'll do is, let me draw the line. So say this is the line I'm given. I'm given the line, that is I'm given the equation of the line. R bar equals to A bar plus lambda B bar. Okay. Now, you know, in equation of a line, A bar plus lambda, R bar equals to A bar plus lambda B bar. This A bar is the position vector of given point on the line. So here I have, say, point A, and its position vector is A bar. And what is B bar? B bar is the vector. B bar is the vector which is parallel to the line. So B bar is this. This is B bar. It's a vector which is in the direction of the line. It is parallel to the line. Okay. B bar could be this way or this way. It is both the ways B bar you can take. There is no problem as such. Because line has two directions. Line has two directions. You know, it is going this way as well as this way. It goes to infinity both the ways. Then finally, I have a point P here. Okay, I have a point P here. Say its position vector is P bar. Now see, position vector of P is P bar, that is with respect to origin. What I have to find is, I have to find the distance of this point from the line. I have to find this distance. Okay, and this distance I call as PM. And remember students, when you say distance, it is always perpendicular distance. Distance means the perpendicular distance. You have to find PM. This is what you have to find. Okay? It is the perpendicular distance that you have to find. PM. Now what I will do here is, see, very simple. I will first go for, see, I will join A with P. I tell you the whole procedure that we are going to follow. We are actually going to derive a formula. Okay, we will derive a formula which will get us PM. Now for deriving that formula, see, the procedure that I will follow is, I will use the Pythagoras theorem in this triangle APM. Okay, once again, I repeat. I'm given the equation of a line. Now from that equation of a line, I have r bar equals to a bar plus lambda b bar. So a bar is what? Position vector of the point on the line. You know this point on the line. It comes with the equation of the line. Then I have a point P in space whose distance from the line is to be found. Now see, this point P also is given to me. What I will do is, I draw a perpendicular from point P to the line. This PM is what I need to find. I join A with P. So I have APM, and APM is the triangle. I will apply Pythagoras theorem here. So when I apply Pythagoras theorem, see what I get. In triangle APM, I will have now AP square is equal to AM square plus PM square. So basically, PM square is AP square minus AM square, and PM is square root of AP square minus AM square, and it has to be positive. You know, this is positive without any second thought. Why? Because PM is the length. So don't think that if you are taking square root, so you write plus minus. No, no negative. It's all positive. So this is what we are going to do. Now in this, you know, when you say PM, PM is a length, AP is length, AM is length. So what I will do first is, now see this AP square. Look at the PM that you found. You found PM as AP square minus AM square under root. Now here, PM equals to square root of AP square minus AM square. What is AP? AP is this length. You know, this is AP, which you can find because you know A, you know P. But what about AM? AM you do not know. AM you will have to find out. AM you will have to find. You know what is AM? This is AM. Look at this. This is AM. This I will have to find. Now, what I do is, in order to find AM, I define AM as the projection of vector AP bar. See, what I do is, I take AM as the projection of vector AP bar. I take it as projection of vector AP bar on B bar. Yes. I take, how do I define AM? See, I say that AM is projection of vector AP bar. This is AP bar. And here you have B bar. This is B bar. Now, please don't consider that you have B bar like this. Okay, so how would you, B bar is only just a short vector. So how would you project it? Nothing like that. You know, B bar you can see, this is B bar. So you can consider B bar here. And then when you say projection on B bar, it actually means, you know, that there is a line of support to B bar. As you know, students, that every vector has its line of support. So see, this is the line of support of B bar. So as such, B bar is only this. This is only B bar from here to here. Okay, this is B bar. But what is the extension? This extension which I have gone for, that is the line of support of B bar. You know, this is this dotted line which you see, it is the line of support of B bar. So what are we going to do? We are going to project AP bar on B bar. Now, when you do that, you know how to project it. The endpoint of AP bar, the endpoints of AP bar are A and P, extreme points. So see, you will project, that is, you will draw perpendicular from A and P, and you know the projection is going to be from here to here. This is projection. And what will that be equal to? Actually, it is this. You see this? And this one is nothing but AM. Is nothing but AM. So what I said just now, I said in order to get AM, what we will say? We will say that AM is projection of AP bar on vector B bar. Okay. So here I write here AM equals to projection of AP bar on B bar. That is, it is nothing but AP bar dot B bar mod B bar. You know this, AP bar dot B bar minus AP bar dot B bar upon mod B bar. That is the formula for the projection. AM is nothing but projection of AP bar on B bar. Now AP bar is what? It is P bar minus A bar dot B bar upon mod of B bar. So you got AP bar. I'm sorry, you got AM bar. So this is AM. You got AM. Okay. And you remember that projection is always a scalar. It's a number. So you got AM. Now what I do is AP. What is AP square? I want AP square. See, I could manage to get AM. I will substitute this here. You see this? I will substitute this here. Now I'm going for AP. I'm going for AP. What is AP? AP is very simple. You know that AP is nothing but mod of AP bar. What is AP? AP is nothing but mod of vector AP bar. Okay. And what is mod of AP bar? It is mod of P bar minus A bar, because AP bar is P bar minus A bar. So now this is, see, I write this as 2 and this as 3. So I will now say using 2 and 3 in 1. Using 2 and 3 in 1. We get. So what you will get? See, that PM, which was the perpendicular distance of a point from the line, it is square root of what it was? It was AP square. What was AP square? AP square is P bar minus A bar, that is AP bar modulus square. Got that? See, this is a P bar minus A bar, AP, so it's square. Minus AM square. What was AM? You remember what was AM? How you had defined? AM was projection of AP bar on B bar. On B bar, right? So it is P bar minus A bar dot B bar upon mod of B bar and square. Okay, this is the formula for perpendicular distance. Okay, so students, now here you might think that this formula is too complicated for remembering. I tell you, you don't have to bother yourself remembering this. What is the reason that I derived it before you? Because I wanted you to learn the technique. So once again, I will go for the technique here. Okay, I will go for the technique. See, the technique is, they give you a point P, yes. They give you the line, yes. The equation of the line is R bar is equal to A bar plus lambda B bar, yes. What is B bar? B bar is a vector in the direction of line, yes. You have a point A here, yes. Which is A bar, yes. This is point P, given point P bar, yes. You will have AP bar, yes. Draw the perpendicular which is PM, yes. You want the length of PM, yes. So in order to get length of PM, you will apply Pythagoras theorem, yes. What is PM? PM is square root of AP square minus AM square, yes. You do not know AM, so you will apply projection of AP bar on B bar. You will apply projection of AP bar on vector B bar. So what is that? AM is AP bar dot B bar upon mod of B bar. So substitute. In place of AM, you will substitute this. In place of AP, you know what is AP. You will first find AP bar, which is P bar minus A bar, and then take the magnitude. This is AP. So when you substitute these all, you get PM. What is PM now? You will get PM as PM is equal to square root of AP square, that is P bar minus A bar, magnitude square, minus AM square, which is P bar minus A bar dot B bar upon mod of B bar and square. See? Just remember the diagram. If you know the concept, writing the formula is so easy. If you learn, see, if you try to learn by heart this, if you try to learn it by heart without knowing the concept, without knowing what is what, it is difficult. Then it is really difficult. I hope it is clear. Please copy this. So let us solve a problem here. Find the length. See, using this, whatever we learned, we will use it here to get the solution of this question. See, what does it say? Here you have to, the question says, find the length of the perpendicular from 2 minus 3, 1 to the line. This is equation of the line given in symmetric form. Okay. Fine. You know, from the symmetric form, see, this is, you shouldn't worry about that symmetric form equation. Okay. Don't think that we did the formula using R bar is equal to A bar plus lambda B bar, which was in vector form. And here we have the symmetric form. Okay. Don't worry. Because you know, from this form, you can always go to that form, and from this form, you can always come to this form. It is one and the same. Now, here, what is important, students, that in this question, they say find the length of the perpendicular from this point to this line. Now, length of the perpendicular is nothing but distance of the point from the line. Okay. So here, what I will do is, see, my solution begins. So, you know, if this is an MCQ question, the question would be framed differently. That is, it will be said, then in that case, it will be said that the length of this from the line is, and then you have 4 options, A, B, C, and D. What you will do, you will find out the length, and any one of the answer is correct. Say B is correct. Okay. So this kind of question you can get in MCQ. You can also get in your respective board examinations. Okay. The idea will remain same. See, I will begin with solution. What is it? I will write P as 2 minus 3, 1. Yes, when it is MCQ, you are not bothered about the solution. You know, you write only those things which matter, because here nobody is interested in the solution. There in MCQ, you just want to get the correct answer. So there you will try solving it faster. But in board examination, you'll have to give the solution in detail. So you take P as this. Now see, the line equation is this. So I will write the DRS of the line. See, I will write the DRS of line. What is DRS of line? 2, 3, minus 1. 3 minus 1 are the DRS. Therefore, a vector parallel to line, a vector parallel to line can be given as, a vector parallel to line can be given as B bar equals to 2I cap plus 3J cap minus K cap. You see this, using this 2, 3 and minus 1, which are the DRS, I wrote a vector parallel to the line. Now, how did I get the DRS? See, this denominator, you know, are the DRS. Then I will go for a point on the line. You know, now we need a point on the line. So a point on the line, I will write from the equation you can get a point. The point on the line is given as -1, 3, -1. How? See, you know the symmetric equation, you write this numerator in the form x minus of -1. You see this? X plus 1 it is, x plus 1. So how will I write x minus of -1? This is y minus 3. And here, this one I will write z minus of -1. Then, you know that after writing this negative sign, x minus x1, y minus y1, and z minus z1. So x1, y1, and z1, these are the coordinates of the point on the line, right? So this is my A. I will write, let this point be A. Therefore, A is -1, 3, -1. Okay. Now you have the whole picture. Before you, you have the line. This is line. And here you have A. This is, I'm sorry, this is point P that you took. Here you have point A. So you will join A with P. Yes, you can always draw the diagram. Nothing wrong in this. Okay, and don't worry that you have to draw a very good looking diagram. Nothing. This is only for your reference. Now you know this is vector B bar. What you will do, you will have the projection of, okay, AP bar on B bar, so that you get AM, magnitude of AM, right? So before that, now you write the formula. What is formula? PM is square root of, okay, PM is square root of AP square minus AM square. This is, so you will now find out AM. What is AM? AM is projection of AP bar on B bar. So it is AP bar dot B bar upon mod of B bar. Got that? This is P bar minus A bar dot B bar upon mod of B bar. It is important that you first calculate P bar minus this P bar minus A bar. So you have point P as this. So see, from point P, you will get P bar. What is P bar? From point P, you will get P bar. P bar will be 2I cap minus 3J cap plus K cap. And what will be A bar? A bar will be minus I cap plus 3J cap minus K cap. So you will now go for P bar minus A bar. So see, P bar minus A bar, that is actually AP bar. Okay, you are calculating AP bar. It is P bar minus A bar. So this minus this. So this is 3I cap. It is 3I cap, 2I cap minus of minus I. Okay. Minus 6J cap, okay, plus 2K cap. This is AP bar dot B bar. So I'll have to get this dot B bar, okay, upon mod of B bar. So let's go for P bar. So this is now, I have now AM equals to C. 3i cap minus 6j cap plus 2k cap dot b bar. What is b bar? B bar here is 2i cap plus 3j cap minus k cap upon mod b bar. Mod of b bar, you know, it is magnitude of b bar. So that is 2 square plus 3 square plus minus 1 square. I'll calculate this. We will now get the dot product of two vectors. You know, this will be 3 into 2 plus minus 6 into 3 plus 2 into minus 1. Okay. The respective coefficients of I cap, j cap, k cap are multiplied and they all are added. So 3 into 2 is 6. So here you have am equals to 6 plus minus 6 into 3, that is minus 18. 6 plus minus 18 plus 2 into minus 1 minus 2. Minus 2 divide by modulus of b bar, which was this. Square root of 2 is 4 plus 9 plus 1. So 4 plus 9 plus 1. Okay. So what is it equal to? See, this is minus 20. You got minus 20 plus 6. That is minus 14 upon square root of 14. That is equal to am is you got minus root of 14. That is what you get. This is am which you got. Okay. Now what you have to do? You have, after am you got, you need am here, which you are going to substitute later. Right now what we will do, we will write this as equation number 3. This is my equation number 3. After this, I'll go for AP square. Okay, what is the AP square? AP square is mod of AP square. You already got AP bar. See here, you have already got AP bar, which is P bar minus A bar. So you get the modulus of this AP bar. Okay, so AP is nothing but mod of AP bar, which is nothing but square root of what is AP? 3 minus 6 and 2. So 3 square plus minus 6 square plus 2 square. Okay, so you got 3 square as 9 plus 36 plus 4, that is square root of 49, that is 7. So this is what you are going to get. AP, you got this. You got AP, this is number 4. Now what I'll do, I'll write using 3 and 4 in 1. Using 3 and 4 in 1, you will get the perpendicular distance. So I write here using 3 and 4 in 1, we get, what we will get? PM is square root of AP square, it was AP square is 7 square minus AM square. What was AM? AM was negative 14. So negative root 14 square. Negative root 14 square. So it is 49 minus 14. Okay, that is 35 under root. This is PM units. That's it. This is what the answer is. This is your answer, the final answer. Now here I would like to say that this question where we found the length of the perpendicular from a point to a given line, there is another method which could be used. Like this method you used where you used the formula. There is one more method which you can use, and there you will not have to use a formula like this. See, there is no formula like this. There we are going to use the method of DRS of the line. You know, using the DRS technique, we are going to get the length of the perpendicular. Yes, but then we will use distance formula there. Okay, now how is that going to be done? You will understand when I will solve the second question from exercise 6.2. Okay, when I will take this problem, you will understand the other method also. Okay, because here we will have to use that method only. Which method? The other method, the second method. So the method which I am applying here, you can also use for the first question. Okay, it's very simple. You will all understand. Do not worry. This is problem number 1 from exercise 6.2. And as you know, we are using the textbook of Maharashtra State Board. So here, now see what this question says. Look at the question. The question is, find the coordinates of the foot of the perpendicular drawn from the point whose position vector they give, drawn from the point 2i cap minus j cap plus 5k cap. So from this point, what does it mean? This is point P. Now, why do they give in the form I cap, j cap, k cap? See, they are giving you the position vector. If they wanted, they could have given only the coordinates 2 minus 1, 5. They could have given only the coordinates 2 minus 1, 5. So what is this point? This is this point, you know, it is P, which they are giving. Okay, that was nothing but this point, P. Next. What is further they are saying? They are saying, find the coordinates of the foot of perpendicular drawn from this point, which is P, to the line. See, now this time they are giving the equation of the line in vector form. Okay. So what they are asking, they give you the equation of the line, they give you the point, and they are asking for the foot of the perpendicular. What does that mean? They are asking for this. They are asking for the coordinates of this point. They are asking for the coordinates of point M, which is the foot of the perpendicular from the given point to the line. Okay. And after that, what they are saying? After that, they are asking, also find the length of perpendicular. See, students, once you get the foot of the perpendicular, you can find the distance formula. You can apply the distance formula and get the length of the perpendicular. So this is the second method which I was talking about. This is it. Okay, this is the second method. So once again, I'm given, see, students, you know, in this question, they could have simply asked you, find the length of the perpendicular. They could have simply asked you, find the, why write coordinates and all? See, they can say, find the length of the perpendicular drawn from this point to this line. See, find the length of perpendicular. Find the length of perpendicular drawn from this point to this line. Same question. We are going to use another method here. So let me now begin with it. Very simple. See, I have the line. What is the line? Line is R bar equals to this. R bar equals to 11 I cap minus 2j cap plus 8k cap. So this is nothing but point A, point on the line. I can write A as 11 minus 2 minus 8. See, you know, this gives us the coordinates of the point on the line. 11 minus 2 minus 8. And what does this give you? This gives you the DRS. This gives you the DRS. So from the DRS, I can write a vector parallel to the line. Definitely yes. See, P bar is 10I cap minus 4j cap minus 11k cap. Okay. So R bar equals to A bar plus lambda B bar. I have written B bar and I have written the coordinates. This is point P. This is point P. The coordinates are 2, minus 1 and 5. 2, minus 1 and 5. What I have to get? I have to get the foot of the perpendicular. That is, I have to get M. See, I have to get the coordinates of this point, which is M. This is foot of the perpendicular. See, I write here the DRS of line. The DRs of line the DRS of line R 10 minus 4 minus 11. 10 minus 4 minus 11. These are the DRS. And I'll find out I will take M as x1, y1, z1. Okay, I'll write here. Let M foot of the perpendicular. Let M be the foot of perpendicular from given point on the line. And M, I assume it to be x1, y1, z1. What I do next is I write DRS of PM bar. See, I write DRS of PM bar will be, the DRS of PM bar will be x1 minus 2, comma, y1 minus of minus 1, that is y1 plus 1, and z1 minus 5. Z1 minus 5. Okay. So this is DRS of PM. Now what I notice ahead is PM bar is perpendicular to B bar, or PM bar is perpendicular to the line. Definitely yes. I'll write here, since PM bar is perpendicular to line, therefore, now students, if two lines are perpendicular, the sum of the product of corresponding DRS will be equal to 0. You know that if two lines are perpendicular, so see, the DRS of line are 10 minus 4 minus 11, DRS of PM are x1 minus 2, y1 plus 1, and z1 minus 5. So what will happen here? See, 10 into x1 minus 2, 10 into x1 minus 2 plus minus 4 into y1 plus 1 plus minus 11 into z1 minus 5. Z1 minus 5 equals to 0. Okay. 10 into this plus minus 4 into this plus minus 11 into this is equal to 0. Why? Very simple, because these two lines are perpendicular to each other. We have already done this. When the lines are perpendicular, then the sum of the product of corresponding DRS components will be equal to 0. The same for DCS also. DCS also the same thing. And when the lines are parallel, then the DRS or DCS are proportional. They are proportional. So here you will get, see what you get. You get here 10x1 minus 20 plus, rather negative, 10x1 minus 20 minus 4y1 minus 4y1 minus 4 minus 11z1 plus 55 equals to 0. So what you have 10x1 minus 4y1 minus 11z1. Okay, this is minus 24. So minus 24 plus 55, that is 55 minus 24. So 51, 31. So minus 31. This is equation number 1 that you got. Now see, after this, what I do next is, see, I will write a variable point on the line. See, I will write a variable point on the line. I write a variable point on the line can be given as, see, this is your line. This is the line that you have. Let me explain this to you. See, what I'm trying to say here is, see, this is the line that you have. This line you have, whose equation is here, r bar equals to this. Now you know that on this line there are infinite points. On this line there are infinite points. Now of those infinite points, you know one point with the coordinates, okay? And you are about to find the coordinates of this. You know this point and you want this. You know, I will write the points on this line with the help of variable, okay, with the help of a parameter. So a variable point on the line, I'll be able to write a variable point on this line with the help of this equation. Now how I do that? See here. You know, students, that in this equation, this r bar that you have, it is xi cap plus yj cap plus zk cap. What is r bar? This r bar? R bar here you have, it is nothing but xi cap plus yj cap plus zk cap, where this x, y, and z are the coordinates of a variable point. What are x, y, z? They are the coordinates of the variable point. You remember, whenever you found the equation of line, you took the variable point as x comma y comma z. Okay. So remember, what is the left hand side? Left hand side that you have is, the left hand side that you have here is xi cap. You have the left hand side as xi cap plus yj cap plus zk cap. This is your left hand side. So from this you will find the coordinates x, y, and z. Let us solve for x, y, z. So here I will write a variable point on the line can be given as, this side you have xi cap plus yj cap plus zk cap, and this side what you have 11 plus, see, let me multiply this lambda inside and then take I cap, j cap, k cap common. So 11 plus 10 lambda I cap. So x will be equal to 11 plus 10 lambda. This is your x. 11 I cap plus 10 lambda I cap. That is, you take I cap common and you will get 11 plus 10 lambda. So x will be equal to 11 plus 10 lambda. Next, see, minus 2 j cap minus 4 lambda j cap. So minus 2 minus 4 lambda, minus 2 minus 4 lambda. Then minus 8, and the z coordinate will be minus 8 minus 11 lambda. Minus 8 minus 11 lambda. This is your variable point. This is your variable point. Now remember, students, this is a variable point on the line. This point which you are getting is a variable point on the line. If it's a variable point, remember, for different values of lambda, it will get us different points on the line where lambda is a real. So please try to understand that this particular x coordinate, y coordinate, and z coordinate of a line are fully capable. This x coordinate, y coordinate, and z coordinate are fully capable of representing A as well as M. You know, these points can represent A as well as M or any other point on the line. It is only a matter of respective lambda. For point A, lambda will be something different. For m, it will be different. For this, it will be different. For this, it will be different. So what I understand is this point, which has coordinates, this variable point can also represent x1, y1, z1. Okay. So I will write, see what I write next. I write this variable point can represent, I write here, this variable point, this variable point can represent m for some specific lambda. So now what I will do, I will use C x1, I will take this as x1, I will take this as y1, the y coordinate, and this one as z1, the z coordinate, and substitute in 1. I will write using the variable point in equation 1. Therefore equation 1 becomes, what it will become, see, it is 10x1. So 10 into 11 plus 10 lambda, 10 into 11 plus 10 lambda, 11 plus 10 lambda, minus 4 into minus 2 minus 4 lambda, minus 4 into minus 2 minus 4 lambda, minus 4 into minus 2 minus 4 lambda, then minus 11 into minus 8 minus 11 lambda, minus 11 into minus 8 minus 11 lambda equals to minus 31. I calculate this. So this gives me 110 plus 100 lambda plus 8 plus 16 lambda plus 88 plus 121 lambda is minus 31. So this is, see here, this is 10 plus 16 is 26, 26. This is 147 lambda, 147 lambda. Okay, 26 plus this is 27, 147 lambda. This is, so this is 110, 118. Okay, so 118 plus 88. So 18 plus 8 is 26. So 126 plus 80, that is 206. So this is plus 206. Plus 206 equals to minus 31. So next you get is 147 lambda is equal to minus 237. So therefore lambda is minus 237 upon 147. See, this is lambda value, minus 237 upon 147, for which this point will get you the coordinates of m. Okay, this is quite odd number, you know, this is quite a difficult kind of lambda value that you are getting, but yes, that is the fact. This lambda which you obtained, when you substitute here, you will get the x, y, z of point m. Okay, so you just can't help it, you will have to calculate it. So I will now substitute. So what will be the coordinates of m? So here you will have, therefore m is, you understand, see, this is 11 plus 10 lambda. So you have 11 plus 10 times of minus 237 upon 147. Students, see here I committed a mistake. I'm sorry for that. You know, this 10 into 10 lambda will be 100 lambda. I remember I said 100, but I made an error. I wrote 10. So this is 100. So I had taken 10 lambda, but it is 100 lambda. So we are falling short by 90 lambdas. Okay. So when you will add 90 lambda here, so you know what, this will get you, it is not 147, but this will be, you can check now, add these lambdas. 100 plus this is 16. So 116 plus 121 is 237 lambda. So this is 237 lambda. So you understand? So what you will get? So you get 237 lambda is equal to minus 237. So this is also 237. And now see, lambda you are getting is minus 1. That's what I said, you know, because you remember I said that it is very weird kind of lambda we are getting. So actually, see, lambda is negative 1. So it was our mistake, rather my mistake. So for this lambda, students remember, for this lambda equal to minus 1, when you substitute this lambda value here, you will get the, when you substitute lambda value in this variable point, that is minus 1, you will get the coordinates of m. You will get the coordinates of m, which is your in. So I will now go for using lambda, we will get, I write here, using lambda we get. Therefore, using lambda equals to minus 1, we get m as, you can check, see, what it was 11 plus 10 lambda. Lambda is minus 1. So 11 minus 10, that is 1, comma. This is again minus 1, so this will become plus 4. Plus 4 minus 2 is 2. And then here you have minus 1. So this is plus 11. So this is 3. 1, comma 2, comma 3. See, you got the coordinates of m. Now, once you got the coordinates of m, which are 1, comma 2, comma 3, we will use the distance formula to get the length of pm. I will apply, therefore, pm. Therefore, by distance formula, that's what they want. What was the second part of the question? The second part of the question was also find the length of perpendicular. You see this? So I will write, therefore, by distance formula, what you will have, pm is square root of, you know this, square root of, see, 1 minus 2 the whole square, 1 minus 2 square plus 2 minus of minus 1, that is 2 plus 1 square, 2 plus 1 square plus 3 minus 5 the whole square, 3 minus 5 square. So what is it? It is minus 1 square plus 3 square plus minus 2 square. Okay, that is equal to square root of 1 plus 9 plus 4. That is root of 14 units. We got the length of the perpendicular. So what was the technique, students? The technique was, we found, what was the second method? I said that there can be two methods. So this is the alternating method. What? You will use the DRS of the given line from the equation of the line, whether it is in vector form or that form, either form you can use the DRS, and you will assume the point M to be x1, y1, z1. You will find the DRS of this perpendicular. Then using the DRS of perpendicular and DRS of line, you will get one equation in x1, y1, z1. Then you will write the variable point of the variable points on the line. Now this variable point coordinates will definitely satisfy this equation. That will get you lambda. Once you get the lambda, substitute lambda and you get the coordinates of m. You get the coordinates of m. Now when they ask you to find the foot of the perpendicular, there is no other method, there is only this method. You will have to use this method only. Okay, but when and after using this method, getting the foot of the perpendicular, you can apply the distance formula to get the distance of the perpendicular, and that is nothing but the distance of the point from the line. Okay, so There are two methods. You can use this method or the earlier method. Any of the method when they ask you the distance of the point from the line. But remember, if they ask you the foot of the perpendicular, then it is this method only. So the choice is yours. Whichever method you want, you can go for. Some students prefer this method, some students prefer other method. But remember, if it is foot of perpendicular, then you have to go for this method only. Okay. You can copy this. These are two more questions. That is number 5 and 6. I have written here along with these answers. You will try solving these problems as homework. These are two problems for practice for you. Thank you.